Hey, this is the third installment of this. And just a couple of points from the previous one that I want to make sure that you understand. Again, by now you should be able to say, okay, the z-score and the standard normal curve are they're just the same. They're interchangeable. When we talk about the standard normal curve, we're talking about z-scores. When we're talking about z-scores, those refer back to the standard normal curve. Standard normal curve is the curve that has a mean of 0 and the standard deviation is 1. We build z-scores and a lot of other things from that. And so let's go back and pick up with the video where we left off. I'll do that. So let's look at, and let me emphasize that this is important for this reason. We're talking about the z-scores, but as we work with z-scores, we found out that the z value is going to be equal to some value, x, minus the mean over the standard deviation. Okay? So what are we doing here? We are normalizing by subtracting off the mean. We're going to normalize for the center of the distribution, for the mean. That's where we expect the mean to be the center. And then by dividing by the standard deviation, we're going to normalize for the spread. Okay? So we're getting the location here, and then we're getting how far out it is, how much of the spread it is. Because this might be measured in one unit, like the feet, and this one's also measured in feet. Because we're dividing feet by feet, we get a value that is unitless. It does not have any units associated with it. So that allows us to compare apples to oranges, for example, if you want to. We can compare the height of humans with the height of chimpanzees or something like that to see which one is different or unusual. So all of the statistics, or not all of them, but the majority of the statistics that we're going to use in this course, the t-statistic and those kind of things, they're going to follow this same form. So that's why it's important for us to understand it at this point. Is that they'll do something that normalizes for the center, and then they'll do something that normalizes for the variance or for the spread. Once you get that value, then you look it up in a table and you find the critical value. So what we're doing with the z-scores, we're going through and we're practicing. We're learning first how to calculate the test statistic, and then second, how to determine if it's a significant result by looking up the critical value for it. And you know, it's really important, you know, just for you to understand the z-score. So let's get on back here to some of these questions that are in the book. For example, in a normal distribution, what proportion of the distribution falls within 1.5 standard deviations of the mean? Okay? And so we would go to the table here and we would look up 1.5. This is the z value of 1.5 is the same as 1.5 standard deviations from the mean. And we see that in this first column here, which is that's the difference, I mean that's the area that's between this value, the mean, and the z-score. So that area right there. So that tells us that it's 0.4332. So within within 1.5 standard deviations, which would be this part right here. So we've got that 1.5 over here. We looked up that value. It's 0.4332. So that means that also over here, a minus 1.5 is going to be 0.4332 also. So you multiply that by 2, or if you add those two together, you're going to get 0.8664. So that tells me that 86.64% of the values of that area is between 1.5 standard deviations of the mean. Out of time for let's go and look at that problem that we had just a minute ago, and let's put those values in here. Again, we put in the minus 1.5, and we put in a 1.5, and if we did our math right, we should get between those two values 0.8663855,974. So you can see that there is some consistency there. This session, hope that you enjoyed it. Have a good day. Let me come back and I want to show you the next problem there that was in that I didn't get to at that point. And there's an applet here that allows us to do that. This is problem 12 here. It says, for the distribution described in problem 11 above, what weight is associated with the 60th percentile? The same program that we were using has got another applet down here. Okay, and we put in the probability here, the mean, and the standard deviation. So for this situation, the mean was 200, and the standard deviation was 40, and the probability, or the quantile, they wanted 60. Remember that the percentile, because we're dealing with area, the percentile and the probability are the same. So you see this does go slightly over by 40 over to here. So the 60th percentile for this particular problem is 210.1. So this answer here, the 60th percentile would be 210.1. And you can do that with a program like this, or you can actually look it up in the table as we did. Look at, here we are, here we go. Okay, the 10th percentile. Okay, and so if we go back to our applet, then it's fairly easy. We just put in 0.10 there, and that percentile is going to be down here, 148.7. Again, those are fairly easy to calculate using the formula. A little bit easier to calculate using the computer program. Okay, well, I'm going to finish up, and this concludes our comments at this point on Chapter 6. I hope you understand that if we decide that we need to talk about something else, that we'll bring that also up and discuss it. Hope that you are doing well with this and